Hello everyone. Very good morning to all of you. We are live now. Can you hear me? Hello. Hi. Good morning. चलो जल्दी से आप लोग अपना हाय हेलो गुड मॉर्निंग अपने चैट में लिख दीजिए तो मुझे पता चले कि सब लोग आ गए हैं तो हम लोग फटाफट स्टार्ट करेंगे। ये एक बहुत इम्पोर्टेंट मेथड है जो हर बार एग्जाम में आता है और काफ़ी लोगों को इस मेथड में दिक्कत भी आती है तो हम इसे आज स्टार्ट करने वाले हैं कैसे करना है इस मेथड को। तो देखिए कि क्या करना है ये मेथड में। पहले तो समझ लीजिए कि ये मेथड बेसिकली करता क्या है। इसका मेथड ये इसको डिटेल में हम और डील करेंगे बाकी के लेक्चर सीरीज में। पहले हम एग्जाम ओरिएंटेड क्या क्या चीज़ें समझनी है कैसे करना है वो देख लेते हैं, उसके बाद में ही हम बाकी सारा डिटेल्स यहाँ पर देखेंगे। ओके, तो आज हम ये रीच मेथड देखने वाले हैं। तो ये रीच मेथड क्या करती है, इसका नाम रेले रीच मेथड है बेसिकली, पर इसको पॉपुलरली रेले रीच मेथड है। पर ये रेले जो है वो साइड में रखा जाता है, रीच मेथड भी बोला जाता है। रेले रीच मेथड क्या काम करता है, इज डज द जॉब ऑफ रेले रीच मेथड helps to find helps to find an approximate solution to the given variational प्रॉब्लम। ये काम ये करेगा। अभी वेरिएशनल प्रॉब्लम कैसा दिया रहेगा, लेट अस सी। हेलो दोस्तों, अगर आप चैट में जरूर लिखिए, प्लीज डू राइट इन चैट दैट हाय हेलो, यू कैन जस्ट टाइप इन चैट गुड मॉर्निंग। या सो व्हाट डज दिस मेथड डू? So the variational problem which is given variational problem, let's say I, we call it I y of x, suppose if we call this, then to this problem, let's say it is some limits from x1 to x2, f of x comma y dash. Okay, this is the problem. Then this is the situation. Your boundary conditions will be given. Let's say you call it as x1 as y1 and y at x2 is equals to y2. This is the condition over here. Now what else is written here? Let us see. We'll write down this thing, an extremal. An extremal meaning a solution. Okay, an extremal would be found as the solution of Euler Lagrange equation. In short, some books I saw that some people do write this as EL equation. EL equation meaning Euler-Lagrange equation. So Euler-Lagrange equation is nothing but dabba f by dabba y minus d by dx dabba f of dabba y dash equals to 0. Now write down here that we approximate the solution. We'll first see the basic theory and then we go for the next part. Okay, the basic yeah. Yeah. Here we consider the approximate solution as y bar of x is equals to, we label this solution in this manner as, let's say we can call this as a1 h1 of x plus a2 h2 of x, a3 h3 of x plus and so on up to an hn of x. Okay, and mathematically this would be written like this. So for those here, mathematical notation is like this: an hn of x, n I'll say ai or ak, something like that. It is ak hk of x, where k runs from 1 to n, like this. Some solution will be there. Now this this here we have what are a1 h and all that we write here. Here hk's are are some known functions. Okay, known functions. We have to find in a case which are constants. Alright. Now there is some rule is there. What are the rules and what are they called? Let us see first. The first note here, we write down the note. Yeah, these h functions which are there, hk of x, okay, number one, are called, they are called shape functions. And second, these AKs which are there are called degree of freedom. Another important thing is that all these functions, third thing, HKs of, yeah, these all HKs have to be to be linearly independent. All right. Okay. So now we have another part over here. Now, what are the choices for edge case? Now, linearly independent, when we say, that means that if we take, that is, if we take all these as, like, say, Ci, H, let's say Ck, we take Ck, Hk of x, k running from 1 to n, it implies, if we take this as equal to 0, it implies that Ck's, all Ck's are 0 for all k. Okay, all k. For all k, for every k, these has to be, this has to happen. Now, what are the choices of edge case? Okay, fourth thing, choices of edge case. Now, there are no definite fixed choices. Please note down that no definite fixed choices of edge case. HK of x. There are no definite fixed choices of xk of x. So what we do here, but still there is an approach which is possible. So we note down this fact and keep, but this comes out of experience. Okay, there are, I would say that there are some types I'll give you that which generally come, but in general we say generally generally we choose h k of x as follows: h1 of x equal to 1, h2 of x equals to x, h3 of x equals to x square, and so on. This is how we choose. So what will happen, therefore, approximate approximate solution is of the form it will become, see, y bar will become a1 plus a2x plus a3x square, like this. This is how it becomes. Or you can even say, or you can even write y bar is equals to a naught plus a1x plus a2x square. Like this also is possible. Both are one and the same, but you just have to remember that you have to take it like this. Okay. Am I audible to all of you? Hello. I audible? Yeah, fine. Okay. So now let us go for the next one. Another choice, and we don't use this choice unless specified or required. Okay. Another choice of h k of x is like this. We can have something like this one. H1 of x equals to x minus a x minus x1 the whole square. The second choice be h2 of x equals to x minus x1 into x minus x2. And the third choice will be h3 of x is equals to x minus x2 the whole square. This can be also a choice. Okay? But this is rare case. We don't use this unless specified. Okay? Now let us take up the question which we can solve and which generally comes in examination. I'll take up one simple question that will help you to understand the method. Yeah, I hope you have written down the theory. Now we are taking up the problem. So question number one we will take. So the first question here we are taking is, yeah, solve, take here, solve using Rayleigh Ritz method and I equal to integral 0 to 1 2xy minus y square minus y dash square dx. Okay. After this, you have y0 of 0 is 0 and y1 of 0 is 0. This is what you have. Okay. So this is the first question that we take. Now let's do the solving part. So this is what you will be given. So what we write here, now we go for the answer. So here f of x comma y dash is given to us as 2xy minus y square minus y dash the whole square. Okay, we are given this. Now what does this become? Let us see. So over here what we are expected to do, and also, and we can write here y0 of 0 is 0 and y1 of 0 is 0. So what we can do, see, we will write down here let the approximate solution be y bar of x equals to, we can use either of the format that we like. So we'll use a naught plus a1 x plus a2 x square. Okay, we use this formula. Now what we do, we substitute our uh, values of y0 and y1 in this. So be the solution, or we'll put this as, we'll label this as 1. Okay, we'll label this as 2, and we will get some numbers. Now let's see. So y bar being the solution, what will happen at y bar of 0? Y bar of 0 now is a naught plus a1 into 0 plus a2 into 0. So what does this give us? ये हमको देगा 0 is equals to a naught, right? So we got this one is here. So this is first part that we got. What does the next thing come? When y1 is 0, also when y bar of 1 we put, we get a naught plus a1 of 1 plus a2 of 1, right? And a naught we have found 0, so here it is 0. Y bar of 1 is also 0, so it is a1 plus a2, right? So we have obtained something very nice now. We have obtained a relation that says that a2 is equals to minus of a1. Alright, we have got this. So now we label this equation as 3 and this as equation 4. So from 2, 3 and 4, what we see is that our y bar changes a bit. Therefore, from 2, 3 and 4, what do we get? Hello, all those who are there, yeah, please do comment in the comment section wherever you are not able to understand. So y bar over here now, what happens to y bar? Y bar of x is equals to a naught will become 0, a1 of x plus a2 has become minus of a1 minus of a1 of x square, right, which is equals to a1 times x minus x square. That is what we have got regarding y bar of x. Now this equation is the new solution. This is the simplified version of the solution, you can call. Okay? Simplified version of approximate solution. Okay. Now our goal here, now our goal our goal is to find a1. Okay. What is a1? We have to find. So let us see what to do now. So here we will call this equation as equation number 5 and we will go ahead. Now what we do, see, f of x comma y dash is there. This, because y bar is the solution of capital F, it means that it satisfies the equation. Alright, so we now replace this by y bar. So f of y bar and y dash we have to find. So what does that become? So for that we will need y bar dash. Okay, y bar dash is to be found, and then we will be able to get the next answer. So what is that? Let us see. So y bar dash is nothing basically. Y bar dash is equal to y bar dash of x. Basically, when we take the derivative with respect to x, it is a1 minus 2 times, a1 into 1 minus 2 times x. This is the answer. Now we got this. Now we substitute this in the main equation of the question that we had got. So here, therefore, f y f of x times y bar dash will be equal to what it will give you. Let us write down the whole part. So we had here as 2xy bar minus the original question that we had got. 2xy minus y square we have. So here it will be y bar square minus. Then there is y dash square. So here it will be y bar dash the whole square. Okay, y dash square we had, so it will become y bar dash the whole square. Now we simplify this by substituting all the given answers that we have found. So here what do we have is 2x y bar is nothing but a naught plus a1. We have simplified this, and so we will write down the simplified version. It is a1 x minus x bar, x minus x square minus, here again it will become a1 square x minus x square minus y bar dash square, it will become a1 square into 1 minus 2x square. Okay, so this is what we have. Now we need to do something more to this. We need to integrate it now. So we'll simplify a bit more. So this will become 2a1 x square minus x cube, right? And then this can be kept as it is, or we can integrate it also. No, not a problem. But then I would suggest it to keep it the way it is. So here we have a1 square into x minus x2 square minus a1 square minus 1 minus 2x the whole square. This is what you get on simplification. Now what we do next? We will now go for performing the integration. So therefore, integrating this from 0 to 1, f x y bar dash. Yeah, this is basically y bar we are putting here. Here you get dx, and then we integrate this. This is nothing but your capital I of y bar. So here we will have integration 0 to 1 full same thing 2a1 x square minus x cube minus a1 square into x minus x square minus a1 square into 1 minus 2x square dx. Now what do we do about this? We are supposed to integrate it. So we can integrate it directly from the calculator, not an issue. So I'll be encouraging, if you are allowed to use calculator, you can directly integrate the main term. So what you will need to integrate is 2a1 integrate 0 to 1 x square minus x cube dx. Integrate this one. Okay, this is the first term that you will have to take a1 square, and then the integration is of this integral 0 to 1 x minus x square dx. Then there is minus a1 square integration 0 to 1 1 minus 2x square dx. 2x the whole square, sorry, 2x the whole square dx. This you have to integrate. So if you are able to integrate directly on calculator, not an issue, or you can then perform the integration manually also. So I'll be directly writing down the answer from the calculator, because uh, this integration is considered to be trivial uh, at the level of when this topic is introduced. Hi, hello, good morning, good morning. Yeah, a very good morning. Now, what are we supposed to do? I would like you to integrate the answer manually, or you can even do by calculator. I suggest, if you are allowed to use calculator, straightforward write the answer. So we would straightforward write the answer here. So let's do the integration. I'll be performing in the calculator here. 0 to 1 we are integrating. So here we have x square minus x cube, right? So the integration is 1 up over 12. So here 2a times 1 over 12 is the answer. Minus a1 square. What about the next one? Here it is square. 1 over 6 is the answer. And what about the last one? Let us see. 1 minus 2x the whole square. That is 1 over 3. Right? You get 1 over 3 as your answer there. Yeah. Let me just see. Is it 1 over 3? Yeah. 1 over. So here further on simplification, what do we get? Let us see. Now whatever we got here, we will be doing the derivative. Here it is a by 6 minus, here it is going to be a1 square by 1 by 6, and here it is a1 square by 3. Yeah, 1 upon 3. That is what we are getting here right now. Yeah. So the what do you got is this. Now basically the LHS is nothing but I. Okay, this is I of y bar. So what you do in this I of y bar, you do the derivative now. So this I of y bar has got converted into nothing but a function of your a1. Okay, it has got converted into the function of a1. So whatever constant we see in this final answer, we now take the derivative with respect to that. So therefore, we say the stationary value, the stationary value is obtained at I. We take the derivative of di with respect to a1, okay, and we equate it to 0. So on taking the derivative, what do we get here? We take the derivative over here, we will get 1 upon 6 minus 2 a1 upon 6 minus 2 a1 upon 3 equals to 0. So now we simplify this. So on simplification, what do we get? Let us see. Here it will be 1 upon 6 minus 1 over 3 minus, yeah, 1 over 3 minus 2a1 over 3 is equals to 0. Here there is a1. So on solving, let us see what does it give us. I think there is some mistake has happened here. Here there is the answer that we have got is slightly gone. Yeah. Hmm. Here there is this error has happened. I would like to rectify this error, that when we substituted here, this is y bar square is there. So here we will have a square. Okay. So on, and here also there is a square. So please do the correction. That's what I was thinking. My answer is not matching with the one which I had calculated. So here when we do the calculation further, so what we will get here, the integration that we need to do will be integration of 1 minus, no, it is x minus x minus x square, the whole square we have to integrate. So here we will get 1 by 30 as the answer rather than getting 1 by 6. Yeah, this will solve the work. That's what my answer was not matching. I was slightly dubious about it. So 1 by 30 here you get. So 1 by 30 when you will do the simplification, here you will get derivative when you take, here you will get 2 by 15. Yeah, this will work now. And so the LCM you can take and get that done. So here it is going to be, you can multiply this whole thing by 5 and 3. Here we can take 6, and here it is 2 by 15, and here it will become 5, so 10, right? So this is 10 here. Still something, when you have your a square and then 30, and then there is this. Okay. Please do the corrections properly, calculate it correctly so that you get your answer. And here it is 2 by 3. Now this is 1 by 6 is equals to 2a1 by 15 plus 2a1 by 3. So here you will get 10, 10 to 12, 12a1 by 15 is 1 by 6. That is what we get. I think we must get 11. I'm not getting 11 over here, I'm getting 12. Some small error still. Let me just see here. Because this should boil down to 11. 2a1 by 6 is correct. Here it is by 30. Here it will be 30, 10, right? Yeah. So here it is 2a by 30. So this 2 will not be there. This 2 is not there, then it will become 11. 30. So this will do the purpose. So 10 and then 30 and then 11. So this will give you 11. I hope you get this. So finally you get your A1 is equals to 6 into 15 by 11. Yeah, no, sorry. What you get is A1 is equals to 15 into 6 by 11. So here it will be 15 by 66. It is 5 by 22. So A1 value you got. Now you will have, now y bar of x is what? Y bar of x we had taken and we had simplified it to, so saying that it is equivalent of, here we had written that it is a1 x minus x square. This is what we have written, right? So your answer is 5 by 22 times x minus x square. This is how you do. Now let me help you with one more problem, because in this there was some calculation error that had happened. So let me help you here with another but a simpler and a similar version of the question that will help you out. Let us take up this question here. solve by Rayleigh Ritz method. That is I of y of x is equal to 0 to 1 y square plus y dash the whole square dx. Y of 0 is equals to y of 1 equal to 1. So again, how do we start here? Here we say that f of x comma y bar y dash is equals to y square plus y dash the whole square. So we will now consider here, let the approximate solution be y bar of x equals to a naught plus a1 of x plus a2 of x square. So therefore y bar of 0 is a naught plus a1 at 0 plus a2 at 0. Okay. Now what it is given is that both are 1. So this implies that 1 is equals to a naught. Right? So this is the first thing that we get. Okay. Next, what do we do here? Y bar of 1, that is a naught plus a1 of 1 plus a2 of 1. What now does it become? This becomes 1 plus 1. Yeah, basically it is a naught. So we can write here a naught plus a2 a1 a1 plus a2. Right? Now what do we get here? We get that, which implies that 1 equals to 1 plus a1 plus a2. Oh, good morning. नाउ लेक्चर ले ही रहे तो बढ़िया ही है, हम बढ़िया, आप भी बढ़िया है, संडे भले ठीक है। चलिए तो अ, अभी क्या करेंगे, यहाँ पर 1 और 1 आ गया है तो ये हम यहाँ पे ऐसे लिख देते a2 इज माइनस ऑफ a1। तो हमारा y बार जो है उसके लिए क्या क्या आंसर हो गए, हम लोगों को क्या पता चल गए, y बार ऑफ x जो है उसका एक सिंप्लीफाइड वर्जन आ गया। क्या आ गया, पहले 1 a1 है बराबर, और a2 हो गया है माइनस ऑफ a1 ऑफ x। तो ये मेरा सोल्यूशन बन गया है। अब यहाँ पर दिस इज माय सिंप्लीफाइड वर्जन ऑफ द सोल्यूशन, दिस इज माय simplified version of the solution. So now what do we do next? We will now find f of x, y bar in terms like we will substitute this in the equation x y bar and y bar dash. So we will need y bar dash also for that. So for that what we will do, we calculate what is y bar dash of x. So y bar dash is nothing but a1 x, a1 minus 2a1 x. Okay, or we can write this here like this, a1 times 1 minus 2x. This is what we can write. what will happen further? In this further process, when we now substitute our answer for f of x comma y bar comma y bar dash, what does it give us? Our function was y square plus y dash square, right? So in this we will, instead of writing y and y dash square, we will write y bar and we will make it y bar dash. We will put now y bar dash. So y bar dash square, we have now got a simplified version 1 plus a1 x minus a1 x the whole square. Y bar dash we have obtained here as a1 1 minus 2x the whole square. Now we will need to perform the integration. We have got that. If we want, you can simplify this a bit more. a1x minus a1x the whole square plus a1 square into 1 minus 2x the whole square. Now we will need to do the integration of this with respect to x. Therefore, integrating 0 to 1 f of x comma y bar comma y bar dash dx. What do we get? Let us see. Integrating 0 to 1, 1 minus a1 x, 1 plus a1 x minus a1 x square. Okay, this full function here, the way it is written, plus a1 square into 1 minus 2x. Yeah. So dx. A very good morning to all those who are joining. We are solving Rayleigh Ritz method. This is a part of calculation of calculus of variation method, which is highly used in something called as finite element analysis. I am not discussing right now where to use and how to use. Right now, our focus is to solve the questions based upon how this works. Okay, so how the questions will be asked in most of the examinations and how they are to be handled during examination. So here we are going to see this. Okay, so here we will have this part here, and we integrate now. So on integration, you can integrate this part directly in your calculator if you are not conversant with the basic integration. Basic integration. So here the integration is, we will have to integrate with 0 to 1, 1 plus a1 x minus a1 x the whole square dx. We will have to integrate this part plus a1 square into 0 to 1. a1 is a constant, so it will come out. Okay, 1 minus 2x square dx. This is the form of integration. So what you will do here, let us write down the integration part directly. You can integrate this directly, there is no harm. So if you get the integration of the whole portion directly, it won't be a difficult part at all. Yeah. So here we will have some constant coming into the picture. So I'll input the answer in the calculator to check how much does it give you. Just a minute. A1 x, uh, yeah, there is a square here also. A1 A1x A1x x square is a square here. Otherwise it would get cancelled, right? So here it will be, yeah. So this is the whole square thing. You integrate it. Here the answer on integration for the first part, you will get this integration. You will get your answer as 30 plus 10a plus a square divided by 30. This is what you will get. What about the second one? Yeah, a1, right? A1 over here, and this is a1 square. And on integration of the second part, then now that one is very easy. You can straightforward do this. 1 minus 2x the whole cube divided by 3 into minus of 2. Okay, and that is going to be 0 to 1. You can integrate that manually. I have shown this integration manually. Here I have done directly. Both the ways it is fine. You can get the answer. So here you have 30 plus 10 a1 plus a1 square over 30, and here it is a1 square. Let us simplify this. How much do we get here? Here you will now, when you substitute the upper limit, and the lower limit, how much do you get is 1 minus 2 is minus 1, so you will get minus 1 cube, so that is minus 1 divided by minus of 6, and the minus the lower limit, when you put 0 here, it is 1 over minus 6. Okay, so that is basically you will get there 1/3 as your answer. So there you get 30 plus 10 a1 plus a1 square over 30 plus a1 square divided by 3. This is your answer that you get. I hope you all are able to understand this. It's okay, no problem. Let the chat increase, no problem. I don't mind whether they are fake or real. I have no issues. Let them watch. They are learning. Good. Thank you. I am happy whoever is joining. As far as they are learning out of it, it is good thing. So here you get your I. This is the I value you get. Now we will do the derivative of I to find the stationary points. We will need to take the derivative. Basically, see, actually you take the partial derivative if there are more number of constants. If there are more constants, then you take a partial derivative. 2 or 3 constants are there, then you take partial derivative with respect to each of the constant. But here there is single constant, so whether you take a partial derivative or you take a regular derivative, which you take, that won't take a problem. Okay, so to find stationary points, we do di by d of a1 equal to 0. Basically, you can even also do the partial derivative, that is rather much general version here. Okay. This is a better general version of the whole thing. Or this is under or you can write. So अगर ज़्यादा constant आते हैं तो you do this way, other do the partial derivative, otherwise it is a simple regular derivative also will work. So what will happen here now? Taking the derivative, how much do we get? Yeah, 30. So when I take the derivative over here, so 30 derivative will vanish. I will get 1 upon 3. Yeah, 1 upon 3 a1. a1. Just a minute. I do this derivative directly now. So 30 upon 30, we have to do the derivative, right? a1. So it is 30 upon 30 plus a1 upon 3, or I'll just write 1. 1 plus a1 square over 30 plus a1 square over 3, that is 0. Now that's what here we get. So what we will do, we'll do the derivative here and let's see what do we get. So this is first one is 0. Here it is 1 by 3. Here it is a1 by 15. And yeah, and here it is 2a1 by 3. That is what we get in 0. Okay. So on simplifying further, what do we get here is we will get 1 by 3 plus, now again here we will need to adjust a bit. So 5 times here, 5 3s are 15 and 10, so 11 a1 by 15, right, is 0. So a1 value we will get, so 1 by 3 is equals to minus of 11 a1 by 15. So a1 value, a1 will become how much? 15 into 3 times, or minus of 15 into 11. So it is minus of 5 by 11 is a1. So finally our y bar, which we had taken as an approximate solution, will come down to be 1 minus 5x by 11 plus 5x square by 11. This will be my final answer for is the required required approximate approximate solution. Okay. So this is Rayleigh Ritz method. You can take there can be many other different questions related to this. Now I would like to do one different kind of question in this one, which is slightly different in notion, and it helps you to handle the differential equation that gets converted into the notion of uh, your partial notion of the functional. Okay, so let us see how to handle such kind of question. Let me help you out. You can try out the questions like these. You can practice these questions. Question 3, you can try using Rayleigh Ritz method. Solve the BVP. BVP meaning boundary value problem. Okay, and these are all our boundary value problems only. I equal to integral 0 to 1 to xy plus y square minus y dash the whole square dx. Okay, 0 less than x less than 1, and then here they are saying is y0 is equals to y1 equals to 0. The answer for this, the answer for this will give you y bar is 5 upon 18 into x minus x square. Okay? This will be your answer. You can try this question. Another question here is this kind. A similar version is there. Only thing is the functional that gets changed is using Rayleigh Ritz method. Using Rayleigh Ritz method. See, I appreciate all the fun that is happening in the chat box, but then yeah, I know it's that yo cool kind of thing, but but right now the most important part is that we understand the method and how to solve the questions in the examination apart from the jokes that are happening there. Okay, I know it's very funny. Yeah, but reels there. That I know you are there. I know. So, but this is very funny. Okay, thank you. You can increase my chats. I don't mind. Yeah. So using Rayleigh Ritz method, solve the boundary value problem. I equal to integral 0 to 1 xy plus 1 upon 2 y dash square dx 0 less than x less than 1. Y0 is equals to y1 equals to 0. Oh no, there is a difference here. I think here they have said y0 is 1 and y1 is 0. This is what they have said. Yeah. So, and the answer for this is, you can try this answer. You will get y bar um, I'll do this with you people. simple otherwise, because there is a different version here. So let me help you out with this. So let us take this question and let's solve. So this is the fourth question. The third question I have given you for the practice. You can try that on your own. I'll do the question number 4 with you guys. Okay. So again, approximate solution. Approximate solution would be y bar equal to a naught a1 x plus a2 x squared. Yeah, good morning. A very good morning to you. So this is here, and then what we do, we will now go for the solutions, approximate solutions that we need. So y of bar of 0, so y bar of 0 is a0 plus a1 into 0 plus a2 into 0. When you do this, here you have said that they have given us that y bar at y bar of 0 will become 1. So 1 is equals to a naught. Another thing what they have said is y bar of 1 will become a naught plus a1 to 1 plus a2 into 1. So when we do this, this is 0 is equals to a naught has become 1, a2, a1 is already this 1, and a2 is also 1, right? So now starts a different part here. So how do we handle this? Let us see how to handle this kind of question. We have a different coefficient here, and all things are going to be slightly different now. So what y bar we will have y bar of so finally here we will have a2 is equals to minus of 1 plus a1. Okay, minus of 1 plus a1, that is what we will have. Now we calculate what happens to our y bar in general. So a naught is 1, right? A1 has remained 1, no problem. What about A2? A2 has changed. It is minus of 1 plus A1 of x squared, right? Multiplied by x squared. So let us simplify this a bit. So 1 plus A1x minus 1 minus A1, and then there is this. Now when we have this kind of thing, here you remember that there is this plus and this x square gets shifted inside also. So you have to be a little bit careful while doing all these manipulations, because we might feel that it gets converted, but it is not getting converted that easily. So what I'll keep it here, I'll rather keep this thing. So I'll keep it 1 plus a1x minus 1 plus a1 the x square. We'll keep it like this only, not too much of change. Now y bar of x is what we got here. Now after this we will perform y bar dash. Okay, y bar dash, when we perform, what do we get? Here it is 0. Okay, so this is a1 here, and then here there is minus of 2 1 plus a1 x. This is what you get, right? So when you do the derivative, this is what you will get. And now comes the substitution for the functional that we have got. So on functional, what do we get? F of x comma y bar dash we have to do. Okay, this is f of x comma y bar comma y bar dash. So the substitution when we take it is x into y, we have to do y bar plus half into y bar dash the whole square. This when we do, let us see what do we get. So x into 1 plus a1 x minus 1 plus a1 x square plus half into y bar dash the whole square. So a1 minus 2 times 1 plus a1 x the whole square. This thing is what we get here. Now be very careful for integration because we have to be on a little bit very clear about what all terms are there with the variable and the constant. So here it is x1 a1 x plus a1 square, a1 into x square, and here then there is 1 plus a1 x cube plus 1 by 2 times a1 minus 2 times 1 plus a1 x entire bracket square. This is our f of x comma y bar comma y bar dash. Now we integrate these terms from 0 to 1. Let us integrate this. So this is basically the I. It is actually, now when we do the integration we will get it as I. So integrated 0 to 1 f of x comma y bar dash dx. How do we get this now? This is integration 0 to 1 x plus a1 x square minus 1 plus a1 x cube plus 1 by 2 a1 minus 2 1 plus a1 x the whole square dx. Okay, this is what we have. Now let us be very careful while integrating the terms here. Hello. Yeah. So those who are integrating, please integrate it carefully. Now on integration here you get is this x. So integration of x you will get x square by 2. Here a1 x cube by 3 0 to 1. Here it is minus 1 plus a1 x raised to 4 by 4. Okay, 1 by 2 remaining outside. 1 by 2 will remain outside, and now we have to integrate this term. So the integration of this term is a1 minus 2 times 1 plus a1 x whole cube divided by 3, okay, whole cube divided by 3, but take the derivative of the, so here you will get minus 2 times 1 plus a1. That's the derivative that we need to take. Okay, so here it's from 0 to 1, 0 to 1, and here also 0 to 1. So let us get this done now. Yeah. So this is basically I of y bar, and that y bar is going to get converted as a function of a1. Okay, so no problem here now. So this is 1 over 2. Here it is a1 by 3. When we integrate here, the limits, when we put 1 plus a1 by 4, 1 by 2, okay, 1 by 2 here we got, and the when we put the upper limit here, the lower limit, the denominator will remain the way it is, into minus 2 into 1 plus a1. I'll just keep it like that. When you put the upper limit here, x and 1, yeah, so here you get a1 minus 2 times 1 plus a1 minus the lower limit. When you substitute, is going to give you only the minus of a1. Okay, that's what you get. Now here you have this getting converted as I. We'll just write it as I for time being, and what we see is that here this gets cancelled. So here you have I equal to 1 by 2 plus a1 by 3 minus 1 plus a1 by 4. Okay, and here there is 1 by 2. In the numerator you have minus of 2, 1 plus a1 divided by 3 into minus of 2 into 1 plus a1. Again you can see that this full term gets cancelled. So what is remaining is 1 by 3. Okay, so here it will be 1 by 2 plus a1 by 3 minus 1 plus a1 by 4 plus 1 by 6. That's the derivative that you get. Did we square it? Yeah, we did. Oh, no, no, no. Just a minute. We have this as, when we put 1, we have cube over there, right? So there is this thing, we will have to do it again. Yeah, sorry. This thing we will have to do it again. Yeah. What is there is, yeah, though the denominator is there, 3 into minus of 2 into 1 plus a1, yeah, that is correct. In the numerator, when we will substitute, we will get cube. So it is a1 minus 2 1 plus a1, okay, cube minus a1 cube we will get. That's the thing that we are going to get there. So we have to be careful now. So it won't get cut also that easily. Otherwise it would have got, but here it is not getting cut easily. So here it is 1 by 2 plus a1 by 3 minus 1 by 4 minus a1 by 4, and plus 1 by 2, and then what we get here is a1 minus 2 minus 2a1 cube minus a1 cube. Alright, and then this is 3 into minus of 2 into 1 plus a1. So basically how what all things happen, because we have to take derivative in other terms also, and then there is that 1 plus a in the denominator. Okay, so 1 by 2 plus a1 by 3 minus 1 by 4 minus a1 by 4 plus 1 by 2. How much does this become? It becomes minus, right? Minus of a1 minus a1 minus 2 the whole cube minus a1 cube over, this is minus of 6 times 1 plus a1. Okay, and then there is, we'll simplify this half, and this gives half minus 1 by 4 will give me 1 by 4. On simplification of a by 3 and a1 by 3 and a1 by 4, how much do we get? I'll get a1 by 12. Okay, that is a1 by 12 there, and here there is half, and there is minus 6, right? So it will become, here this is minus 1 by 12. Now see, when you take that minus sign out, here you will get a1 plus 2 cube, and there is a minus sign will come, and there is already a minus, so minus minus makes it plus, and so this is a1 cube here, like this. So 6 times 1 plus 6, no, not 6 will not be there, then there will be a1 alone. A1. Okay. That's what we get now. Now this here is D. No, this is I, right? I. समझ में आ रहा है? Okay. So what we do now, we will take the derivative with respect to I. So taking di derivative, switch चालू कर, कहीं दबाई છે कहीं છે हाँ. So dA1 here, when you take the derivative, you get 0 plus 1 by 12. Now we need to take the derivative over here with the respect to this. 1 by 12 will come out, and we will have to do the derivative of the entire portion up there. So let us do the derivative d by dA1 of 1 plus a1 a1 plus a2 cube, sorry, a1 plus 2 cube plus a1 cube. When you do the derivative here, what do we get? Let us see. 1 by 12 plus 1 by 12. The derivative when you do, here you will get in the denominator a1 the whole square. Now this is 1 plus a1 times 3 a1 plus 2 square plus a1 square into 3. That's the derivative that you will get, minus here you will have the whole numerator back, a1 plus 2 cube plus a1, yeah, a1 here you will have, and then there is a1 cube times the derivative of 1 plus a1, that is 1 only. This is the derivative that you will have. So when we separate the, and this derivative is equals to 0 that we will be saying, right? So when we separate it over here, this you can keep it di by da1. So here, therefore 0 equals to 1 by 12 plus 1 by 12, and here you separate out the denominator also. So on separation of the denominator, what do we see? It is going to be 1 plus a1 into 3 times a1 plus 2 square plus 3a1 square. Okay, this is what they have given us, and then what we will do here, not much of solving would be possible here. 1 plus a1 square minus a1 plus 2 the whole cube plus a1 cube over 1 plus a1 square. Okay, so here when you do the simplification, let us see how much it boils down to. So this gets cancelled a bit, and yeah, you have, but in that ratio it comes. So what you do now is this: 0 is 1 plus, we will have 3 times a1 plus 2 whole square plus a1 square divided by a1 plus 1 the whole square. I'll write like this, that's much easier. And here you have, yeah, you can take 12 on the other side, multiply throughout by 12, you will get that. And here you have this one, right? a1 plus 2 plus a1 cube over 1 plus a1 square. Now when does this equation become 0? That is what we have to check. So now we will need to solve for this equation. So on solving, let's see. Let me just check how much do we get here. This polynomial is there which we will need to solve. So this is what you get at the end. Now there is no definite a1 we are not getting here. So we can first, what we can do is we can multiply a1 all throughout and we can get rid of the denominator. So it is 0 equals to 1 plus 1, instead of 1 you will have now a1 plus 1 the whole square plus 3 times a1 plus 2 the whole square plus a1 square here as a bracket, and here there is a minus sign is there, right, for each of them. So here you will have this as a1 plus 2 the whole cube minus a1 cube. Alright, so you get this. So let us expand the terms. We will need to expand it. So instead of a1 I'll just write a now, because it's all in terms of a alone. So let a1 equal to a. So 0 times a square plus 2a plus 1, and then there is 3 times a square plus 4a plus 4 plus a square minus, here this is going to be cube. So cube, it is going to give me a cube plus 3a square b, right? So 3a square into 2 plus 3a into 2 square plus 8 minus, here it is a cube. Okay, so this is a square plus 2a plus 1 plus 3 times, this is 2a square plus 4a plus 4 minus, this is going to be a cube plus 3a square into 2, and here it is 6 and then it is 12, right? So 6a square 6a square, and then there is 12a plus 8 minus a cube. Okay, so a square plus 2a plus 1 plus 6a square plus 12a plus 12 minus of a cube minus 16a square minus 12a minus 8 and minus a cube. Now we will collect the terms. So here it is minus a cube 2 times how many is 2, 14, okay, 14 minus 12, so plus 2, plus 2, 8, and then how many constants? 1, 13, and then there is this 8. So 12 minus 8 is 5. Sorry, 12 minus 8 is 4, and then plus 1, so that is 5. So you have basically a cubic expression to be solved. So you will need to use a Cardano formula, or you can use your calculator to solve. So a cubic, okay. So cubic equation calculator you can solve here, and then you will get your answer. So I'm taking a solving of this. Minus 9, then C is 2, and here it is 5. So you get 3 values here for A. 3 stationary points you will get, because it's a cubic thing. A equal to minus of 4.59924 x equals to minus of 0.6893 and here yeah, another value is A, or you will have 0, or you will have A equal to 0.78856. So 3 values you got because of the solution, the nature of the solution, right? So the derivative they brought into the picture. Generally you get 1, the problems that we saw. So here you get 3 solutions. So you have y, because see it's an approximate solution, so each one will work. So your y answer now becomes the one that we had found. Yeah. So your y is of the format this one, 1 plus ax minus 1 plus a1 x square, right? So 1 plus a1 x minus 1 plus a1 x square. This was the solution. So you have 3 choices for y bar now. So solution here, y bar is equals to 1 minus 4.59924 x minus 1 plus, here this will become minus 1 and plus, right? So it is plus of 3.59924 x square. This one, or you can have, or the answer would be y bar equal to 1 minus 0.68932x, and then there is 1 plus over there. So this will give me 1 minus 0.68932 is, here I have plus of, oh, here 0.31068 x square y bar is equals to 1 plus 0.78856 minus into x minus here you will have 1.78856. There are three solutions here possible. Now see, when generally such a question doesn't appear, I think there could be a mistake in the question. I have an alternate version of the question also here with me, but then you can try that for yourself. The answer comes a very nice solution here. So the question here is, you have using Rayleigh Ritz method, Rayleigh Ritz method, solve integral I equal to integral xy plus y dash the whole square by 2 dx. Okay, 0 to 1 x less than 1. Now see, our values we had, x is always between 0 and 1. So yeah, one more thing was there, right? So this solution in the above question, these two will be discarded. These values we will, no, we won't be able to discard, right? Because it is a values. A values we want, x values we want. So here is 0 to 1, and the solution is now y0 is 0 and y1 is 1. You try with this. Is 1 over. If you try with this, you will get a good answer, and the answer is, in that case, the answer comes is a very nice and sophisticated one, the one that we tried. Y bar is 1 upon 4x into x minus 1. This is the answer. So I hope the method is clear to you. If at all any difficulty, please let me know next time. Okay? Thank you. हाँ वो बहुत बड़ा आ रहा है. The answer that you got are correct, that there are three answers, no problem, but then we don't have to worry about those three answers. Uh, I think, see, in the book which I had, the question has some misprint. I had the question which they had given with a wrong solution. I tried to give you the correct one. Y0, when you take 0 and when you take y1 as 1, here you will get this answer. We had taken the choices in a different way. So that's why I gave you the one which is uh, difficult version. So I gave you that solution. Do not worry for that solution. You find out this one with an easy method. Okay. So this is a portion of Rayleigh Ritz method on my side. I will do one more type of question on Rayleigh Ritz method in the next part of the live lecture, in which a difficult version is taken into consideration, and it talks about how variational is to be dealt. Now, what is the variation and other thing? Uh, I'll explain you in detail in the next part. Okay. So till then, thank you for joining in. I will see you in the next video lecture. If you have any doubt or queries, please let me know in the chat box. Any doubt? Death, are you there? Thank you so much. Thank you. thank you for being a very wonderful and a great audience. I wish all the people, those who are there, they would have come. But thank you. Thank you for joining in. What wheels are you there? What wheels is not there? Okay. Thank you for joining. We will end the stream now.